IOE 413 Healthcare Quality Study Guide. This question wants you to consider an adverse event or complication that can be modeled using a binary variable. Define the probability of a patient having that adverse event as P. So P is the probability of a patient having this adverse event. Suppose a logistic regression model of the following form has been developed. That form would be the natural log of P over 1 minus P is equal to alpha plus the sum I is equal from 1 to n of beta sub I, x sub I, and n is the number of predictors, and the predictor variables are x sub I, and so there's some coefficients beta sub I and a constant alpha in the model. What this question wants you to do is derive an expression for P from this, because that is used in risk adjustment modeling, the probability of a patient having an adverse event, P. So here's the logistic regression model that we want to begin with. And to make our notation simpler, so I have to do less writing, let me just define some variable, I'll call it Q, to be the right-hand side. It's alpha plus the sum from I is equal to 1 to n of beta sub I, x sub I. Okay, so then this logistic regression model will be the natural log of P over 1 minus P is equal to Q. Okay, so the first thing, obviously, that we're going to end up wanting to do is to just basically take the exponential of both sides. And then what's going to happen is that this will reduce down to P over 1 minus P, and we'll have e to the Q on the right-hand side. So we have P over 1 minus P is equal to e to the Q. We multiply through both sides by 1 minus P, so we end up with P is equal to 1 minus P e to the Q. Now, let's distribute e to the Q through on the right-hand side, so we have P is equal to e to the Q minus P e to the Q. Bring P e to the Q to the left-hand side, so we have P plus P e to the Q is equal to e to the Q. Now let's write this slightly differently as 1 plus e to the Q times P, that's just factoring out P, is equal to e to the Q. So dividing through by 1 plus e to the Q gives us P is equal to e to the Q over 1 plus e to the Q. But remembering that Q was defined just for convenience sake as alpha plus the sum from I is equal to 1 to n of beta sub I, x sub I, we can derive the final result over on the right-hand side, which is P is equal to, what we're going to do here is substitute Q in. So we'll have e to the alpha plus the sum from I is equal to 1 to n of beta sub I, x sub I, over 1 plus e to the alpha plus the sum I is equal to 1 to n of beta sub I, x sub I. And that is our expression for calculating P from a logistic regression model.